Hey there, and welcome back to Quite Basic Math. And last lesson we talked about numbers. Now we're talking about equations. Well, we from the last lesson you understand what equation means. If I say what is an equation, you know what I'm talking about. The equal to sign has to be there. All right. Now I'm going to be classifying equations basically because this is a quite basic lesson, so it's important that you understand that things will be made quite basic here. Now you can classify different equations based on their degree. What do I mean? We talked from last class that if you have a raised to the power of m here talks about your degree or your exponent or your index. So now if I write an equation characterized by y, okay, so when I say y equals to ax plus b, what you have here is a linear equation. Okay, this is a linear equation where your a and your b are real numbers. Okay, I'm sure we remember this. This is a linear equation. We call this linear. Okay, call this linear. Then you could also have a quadratic equation. Now, why was this called linear? It was called linear because the degree of x here is 1. X raised to the power 1 is the same as x. For a quadratic equation, I'm sure you could guess what that would be. Your y equals to ax squared plus bx plus c, where your a, b, and c are all real numbers. Okay. Now, one thing you must take note here in your quadratic equation is that your a must not be equals to 0. If a is 0, this nullifies this and reduces it to a linear equation. So your a must not be 0. Watch out for that. Imagine I have y equals to ax squared. Your b and c might be 0, okay, but your a must not be equals to 0. If you have b to be 0, you could have a quadratic equation like this. Now if b equals to 0, let's see what I'm saying. Now this means that your quadratic equation becomes y equals to ax squared plus c. This is still quadratic. So what makes it quadratic is the degree of x here. All right. So your c also can be 0. What happens if c is 0? This reduces to y equals to what? Ax squared plus b plus bx, and this is still quadratic. Why? Because of this degree of 2 we have on x here. The highest degree is what I'm talking about. Now, what if both b and c are 0? This is still quadratic. Why? Because you still have your degree of x to be we still have it there. So this is ax squared and this is still quadratic. So it's important that I take note here. For your linear equation, we said the highest degree must be 1, right? But your a could be 0, your b could be 0. It depends on the case, but we are not going deep into that. This is a quite basic lesson. All right, you'll discover that your a is your slope. Okay, so your line could be slopey or your line could just be horizontal or completely vertical. What that's what I mean. It could be horizontal or vertical. So the value of a here is what will determine, but the point is it remains a line. It remains linear. So don't say because I said quadratic equation your a must not be 0. Also here your a must not be 0. Your a could be 0 for a linear equation. Just that this a here tells us if it's going to be slopey or not. So if your a is 0 here, you have an horizontal line, right? And if you have an horizontal line, in the case where you have something like this, let's assume we had x equals to ay plus b. In this case, if your a is 0, you have a vertical line. Okay, you must take note of that, or what you call your y-axis. If your a here is 0, you have your x-axis. Okay, let me just draw it out for us to see. So if your a is 0 here and if your a is 0 here and your b is 0 as well, please, if your b is 0 as well, you're going to have an horizontal line. Like I said, it's going to be your x-axis. Actually, that would be y equals to 0. And in this case, if your a is 0 and your b is 0 likewise, that is, if you have x equals to 0, this is also a line. However, it's going to be your vertical axis. Okay, your vertical axis. You must take note of that as well. Okay, moving on. Now let's see another type of equation that you could have. You could also have cubic equation. An equation can be cubic. For a cubic equation, I'm sure you already know what that would look like. That's y equals to ax cubed plus bx squared plus cx plus d. However, your a must not be equals to 0. So that implies that you have a cubic equation at all times. Now you could also have a quartic. For the reason of this class or for this lesson, we'll just stop at quartic. You could have a quartic equation. What happens then? You have y to be equals to ax to the power 4 plus bx cubed plus cx squared plus dx plus e. In this case, again, your a must not be equal to 0. so that at all times you have a quadratic equation. However, your B, C, D, and E could be 0. I'm sure you understand what I mean from what we saw in quadratic equation. So for the purpose of this lecture, these are the classifications that we could have. You could go on and on. You could have degree 5, degree 6, and so on and so forth. But the purpose of this lesson, and to make things quite basic as possible, we would only discuss linear equations and quadratic equations shortly before we talk about simultaneous equations. Please stay tuned to this, and do well to like and subscribe if you have learned anything so far. Alright, let's move on. Now, if you have let's say this, if you have something of this form, okay, yeah, so now let's start with the linear equation. Let's start with our linear equation. Now, we said linear equation takes y equals to ax plus b form. Is that not so? Which we call equation of a line. In some other textbooks, you might see it written this way. It's the same thing, where your m is your slope and your c is your y-intercept. Okay, but we're not going to be going deep down into coordinate geometry now, which is what all of this is about. But we're just going to look at linear equation on a basic platform. All right. So now, if you have a linear equation and you want to solve, so imagine you have y to be equals to 0, and then you have to solve 2x plus 5 equals to 0. Can you see what I'm saying here? Now you have to find x. This is a very simple linear equation. All you need to do is subtract 5 from both sides. If you do that, you'll be able to have 2x be negative 5 and your x be negative 5 over 2. I believe everyone can solve this. Alright, this is a linear equation, a simple linear equation. Now you could be given simultaneous linear equations. You have two equations that you are asked to solve simultaneously. Now, before I move on, you must take note of something, that whenever you have an equation, right, or let's say you have one unknown, you just need an equation to solve that. Unknown here is a variable. For example, look at this equation: 2x plus 5 equals to 0. The number of unknowns you have here is 1, or the number of variables you have here is 1. So you just need one equation to solve it. Now imagine you have let's say you have 2x plus y plus 5 equals to 0. Now you have two variables here, or two unknowns here. For us to solve this equation, we need another equation that also has two variables, okay? Or we need another equation or another relationship to let us know more about these variables. So if I then say 2x minus y plus 6 equals to 0, if I do this, what I have done is I have now been able to give a more solid information about how to go about solving x and y, solving for x and y. So it's important that you know that if I have one unknown, say x, or one variable, I need one equation. Okay, if I have, say, two variable x, y, I need two equations. If I have three variables, say x, y, z, I need 3 equations to be able to solve it. So from this knowledge, you must know that this knowledge will guide us to understand how to solve simultaneous equations. So let's quickly give an example of a simultaneous equation, and let's see how we can go about that. I hope you're learning. Okay. Okay, so look at this example. Now imagine you have x plus y equals to 5 and x minus y equals to 1. Now this, we have two variables here, and you agree with me that since we have two variables here, we need two equations, and this is we have solid information about how to solve the two equations. Two are unknowns here. Now to solve for x and y here, what do we need to do? Now you must see that there are different ways to solve simultaneous equations. Okay, so you could either use the first method, that is quite easy to go about, is to use what we call your substitution method. Yeah, you could use your substitution method to solve it, or you could use elimination method, And the third one is your graphical method. For the purpose of this lesson, there are other methods one could use. We have the matrix method as well. For the purpose of this lesson, we'll strictly be talking about these two. But let me just write other methods that you might come across. You could solve it graphically. You could solve it using matrix method. Your matrix method could either be using Cramer's rule, which we call determinants method, okay, or inverse rule, or using your inverse method, okay. However way, you could solve the simultaneous equation with these methods. But let's just talk about substitution and elimination. If you want to know about the rest, you can as well leave a comment in the comment section that you want to know about this ones. All right, so I organize tutorials in case you want to learn more about mathematics, any area at all. It doesn't have to be these quite basic areas. It could also be tougher areas, university mathematics, anything at all. I'll make them quite basic for you. All right, now substitution and elimination. Let's start with substitution method. What do you need to do to substitute here? Now, if you look at equation 1, if I name this equation 1 and this equation 2, what do I need to do? Now, from equation 1, I could let x from equation 1, I could let x to be equals to 5 minus y. If I do this, I need to substitute. Now that's where we see the word substitution method from. I just need to substitute the value of x back into equation 2. And if I do that, what will I have? Then my x, I can say substitutes x, yeah, right, from 1 into 2, from 1 into 2. And now if I do that, what will I have? I will have, instead of x minus y equals to 1 that you have in equation 2, you will now have 5 minus y equals to 1. And this is 5 minus 2y equals to 1. And this is 5. You can just subtract. There are different ways to go about this, really. You can subtract 5 from both sides, and that will be negative 2y equals to minus 5 plus 1, right? So this is minus 2y to be equals to minus 4. This implies that my y equals to minus 4 over minus 2, which is equals to 2. Quite basic, right? Okay, let's go over this part again for some of us that might not understand what we just did. Because so basically you have 5 minus 2y equals to 1, right? So minus 2y equals to, if you subtract 5 from both sides, the 5 on the left hand is gone, then negative 5 on the right hand plus 1. You know we had 1 here, and if I have just 1, it's just plus 1. Minus 5 plus 1 is negative 4, okay? So minus 2y equals to minus 4. So to find y, to isolate y, divide both sides by negative 2. And that's how we came by this. Alright, I hope we are learning. Now that we have found the value of y, to find x, recall that we said x equals to 5 minus y. So this implies that your x will be equals to 5 minus 2, meaning your x is 3. We have found the values of x and y. So x and y are respectively 3 and 2. Let's check. If you put the value of 3 here and the value of 2 here, you get 5. That's correct. If you put the value of 3 here and you put the value of 2 here, you get 1. That's correct. 3 minus 2, 1. 3 plus 2, 5. So we can see clearly that substitution method could be used to solve simultaneous equation. Now let's see elimination method. B. For elimination method, okay. Now to solve elimination using elimination method, let's still solve the same equation, okay, so we don't find something else. X plus y we said was 5, okay. We said x plus y was 5 and x minus y is 1. Alright. Okay, sorry. So x plus y is 5, x minus y equals to 1. Now to use elimination method, all you need to do is from equation 1 and equation 2, depending on what you want to eliminate. If you want to eliminate y, what you need to do is this: you just add the two equations, because y here is positive, y here is negative. Now to add two equations together, you add the left side and you add the right side, then you have your equal to. So what do I mean? So if you want to eliminate y, that is, you add equation 1 to equation 2. Since equation 1 is x plus y on the left and x minus y on the right, that means you have, x plus y on the left for the first equation, x minus y on the left for the second equation. And don't forget, I said you add the left to the left and your right to the right. So you have x plus y plus x minus y. Do you see what I did there? This plus this equals to 5 plus 1. Now if you do this, you can see that this is plus y minus y. That is eliminated. X plus x, you have 2x, and this will be equals to 6. So your x now will be equals to 6 divided by 2, which is 3. Yes, this is synonymous to what we got here, so which means we're on the right track, right? So now for us to find y, we need to eliminate what now? We need to eliminate x, right? So eliminate x. You could eliminate x or just substitute it, but since we are using the elimination method strictly, let's use the elimination method as we said. So we can do equation 1 minus equation 2. If we do this, we'll be able to eliminate our x. So if you eliminate x by this, so doing, from the knowledge of what I just said now, you could say x plus y minus, open a bracket please, minus x minus y. The problem is opening a bracket. Once you are doing the operation subtraction, you need to be very careful to open your bracket, okay? Because it will guide you to two terms such as this. If you don't open your bracket, you could make mistakes while trying to solve, okay? Now this is equals to 5 minus 1 on the right of both equations. Now if I open this bracket, x minus x gone, right? Then y minus y. Don't forget in numbers that we said if two negative numbers, real numbers, multiply each other, you have a positive result. Go check the previous lesson, okay? I said that. So this will be 2y equals to 4, and this means that your y would be 4 over 2, and this is equals to 2. This is synonymous to what we got in substitution method. We can see now that I believe at this point in time you can be able to solve simultaneous equations using substitution and elimination. Now for substitution, it's quite simple for any case, but this case of elimination was quite simple for many of us because the coefficient of x and the coefficient of y here are both the same. They are 1. Okay, so it is easy for us to solve. Now what do I mean by coefficient? Someone is asking. Okay, so if we have 2x, the coefficient of this is 2. So the constant by which the variable is being multiplied by is what we call our coefficient. So take note of that. This is constant and this is your variable, okay, or your unknown. I think we said that in the last class. All right, so let's see a much more technical question that we could use elimination method for again, because like I said, for substitution at this point I believe you could try anything yourself. Now look at this example. Let's see this example, example 2. All right, see this example. Now if I have x plus 2y this time equals to 1, and let's say x minus y equals to 5. Now look at this. This is quite different. Why is this different? As a matter of fact, let me say 2x minus y equals to 5. Now look at this example. This is equation 1, equation 2. Now this is quite different from what we have earlier on. Why is it different? For us to use the elimination method, you know we said we should add up and subtract. If you add this up, you will not eliminate either of the variable. If you subtract this 2, you will not eliminate either of the variable. Now for us to eliminate this, it's important that we do some interesting stuff. And what are we talking about here? Okay, they're quite basic actually. Now what you need to do here is this. For your equation 1, whichever one you want to eliminate is what you focus on. Now which one should we eliminate? Take a second. Which one did you choose? Well, I'm going with x. I hope you chose x too. Okay, so if for you to eliminate x, right, you need to look at the coefficients on both equations. For equation 1, your coefficient is 1. For equation 2, your coefficient is 2. Now you want to make either of them, right, look like each other. Does that make sense? Let me come again. You want to make these two guys to look like the same, right? You want them to have the same coefficient. That's what I'm saying mathematically. All right, for us to do that, you can decide to multiply equation 1 by 2, right? If I multiply equation 1 by 2, we have 2x here. Is that not so? and then I can use my elimination method as we know it, or I can divide equation 1 and equation 2 by 2. If I do that, I will have x over 2. I have so you can divide it by well, what's the aim? Okay, sorry, you can divide equation 2 by 2. Yes, if you do that, you'll be able to have x here, and this 2 also will be x. But the easier thing, so if we don't have fractions, if I divide it by 2, this will be fraction, this will be fraction. That will be quite ambiguous, right? Well, for this level, right? So let's multiply equation 1 by 2. If I do that, since it's an equation, so one thing you must take note about equations is that if I have an equation, say a equals to b, for me to let this equation to remain valid as an equation, if I multiply a by 2, I must also do the same on the right hand side. So this rule is important in mathematics. Anything, if you have an equation means a quantity is the same as the other. So for you to tamper with any quantity on either side, you must tamper with both sides. Alright, so for that reason, if I'm multiplying this equation 1 by 2, I mean every part of it, on the left and on the right. So I will have my new equation 1 to become 2x plus 4y equals to 2. Did you see that? 2 times x, 2x, 2 times 2y, 4y, 2 times 1, 2. Then I now have, let's call this equation 3, because it's a modified version of equation 1. And then your equation 2 remains what it is. Now, if you look at what we have here, we now have similarity. We have this, which is something we can now do from what we have learned previously. Now, if you subtract this, clearly, since you're eliminating x, if you subtract equation 2 from 1, you would have 2x, right, plus 4y minus 2x minus y equals to 2 minus 5. Is that not true? And if you open this bracket, this will be 2x minus 2x, right? 2x is gone. Then 4y plus y. Why is it plus? Don't forget, minus. So this will give us 5y to be equals to minus 3. 2 minus 5 is negative 3. So your y now will be minus 3 over 5. So this is the value of y. What about x? Now to find x, since we are strictly using elimination method, you don't have to use elimination method all through, okay? You can mix either. You can do substitution method here. How can we do substitution method here? Just take the value of y and plug it into equation 2. You would get x. Or you would multiply equation 2 by 4, right? So you can have what you have here and then add up. That would get rid of your y and you find x. Either way, but I want to choose to use to substitute, because I think that's a wiser thing to do. Now from equation 2, wiser, I mean easier, okay? From equation 2, what can we do? We said 2x minus y is 5, right? That means that your 2x equals to 5 plus y. Is that not so? And this means that your x now will be equals to 1 over 2 into 5 plus y. So what will be your x now? You have 1 over 2 into 5 plus minus 3 over 5, right? So this will be equals to, if I open this bracket, this will be 1 over 2 into, the LCM I have here is 5, is that not so? And I will have 25 minus 3. And this will give me 22 over 5 multiplied by your half, okay? The half outside there. Okay, so what would you have? This will be, alright, are you still here? I hope you're here. This will be 11 over 5. So the value of my x will be 11 over 5. Like as usual we do, let's check if this is correct. So the equation says that x minus 2y equals to 1. We said x is 11 over 5 minus 2 into what is y? Y is minus 3 over 5. So let's see if the left is equal to the right. This is 11 over 5 plus 6 over 5. So at the end of the day, alright, so sorry, something's gone wrong somewhere. Multiplying this by 2, you have this, then okay, 5y minus 3 over 5. Alright, then for your x, we said 2x is 5 plus y, so 2x equals to 1 over 25 plus y, 1 over 25. It's minus 3 over 5. Okay, 5, we said this is 25 minus 3, this is 22 over 5, which is 11 over 5. Yes, so x minus 2y is 1, so it is 11 over 5 minus 2 into minus 3 over 5. Okay, and this is 6 over 5, which is 17 over 5. Okay, something is fishy here. This should give us 1. Let's try for the other equation. 2x minus y equals to 5. 2x minus y equals to 5. 2 into 11 over 5. God, minus what's y? Minus 3 over 5. Okay, so this is 22 over 5 plus 3 over 5. This is 25 over 5, and this is giving us 5. This is correct. But equation 1 isn't consistent with what we have in equation 2. Now for this kind of question, one would say they're not consistent. No, that can be we can't say that for this because clearly would have seen some form of inconsistency if that were to be true. Okay, let's see what went wrong. Let's carefully check what went wrong. Okay, f 5 plus y, 5 plus y, 5 minus, that's 5, 25. Okay, all right, so let's alright, so this will asterisk this. Okay, you could try it. Yourself and check. Let me see if you're following. Try it yourself using another method, and let's see what you get in the comment section. Alright, let's quickly introduce quadratic equation, but that's how to go about it anyways. Let's quickly introduce quadratic equation. Now if you have y equals to ax squared plus bx plus c, okay, something of this form, sometimes you could have your equation paired with a linear equation, say ax plus b, and then you have to solve this simultaneously. Now to be able to go about this, for this lesson we don't touch this. Okay, we are going to start from where we stopped here in the next lesson. I hope you learned something. Alright, you can try this as a form of DIY. Okay, try it as a form of DIY. Let's see what went missing here. Alright, thank you for joining. I hope you liked and learned something. Like, subscribe, and comment. Leave your comments to see what areas you think you'd like to understand better, and watch the other videos to know where we're coming from and how we got here. Thank you for watching. Why Basic Math.